Albert-László Barabási is a physicist and renowned network scientist joining us from Boston, and we're truly delighted to welcome you to this year's Global Chess Festival.
Thanks, Panda. It's a pleasure to be here. There were years when I could be there in person, this time only in spirit.
We appreciate it. Your work has helped unveil the hidden order behind various complex systems with the help of network science, a research field that you pioneered, and it led to help explain the emergence of many types of networks. This year's theme is Women in Chess, Women in Science. Therefore, you are the best person to ask the following question: how do women in science compare to men?
That's a very interesting question, and it's a question that my lab has been actually studying in the last 5 years. But not only in my lab, but this is a subject of study in many, many research labs in the last few years. And the opportunity is really given by the fact that within science, we now have the publication records of all scientists from 1900 till today. And with the new kind of machine learning tools, we can also identify the gender of most scientists. And so it creates an ideal playing field to start asking the question, what is the performance and what are the success differences between women and men? And why am I saying these two words is because when it comes to trying to understand success and recognition, we need to systematically distinguish two different things. One is performance, that is, what does the person do? And the other is success, which is how does the community sees the work of that person, whether it acknowledges it and whether it is being rewarded for that. And in science, the performance is relatively hard to measure because we don't know how good is a paper that you wrote. We only know the impact of that, which is somewhat of a success measure because it's provided by the community rather than done by the scientist itself. So the question was, how could we really start understanding these terms of performance and success, and what are there systematic differences between men and women? And this is not an area that we have started. There are other people who have worked on that, and there have been a number of research studies previously to our work where they looked at specific scientific fields like biology, social science, and so on, and they systematically documented that there are persistent gaps between the men and women, both in terms of productivity, and what is how many research papers does a scientist write, as well as both in impact, which is what is the impact of that work? Are they very, very highly cited? Are they well received or not so? And this has been very consistent across all the fields that men have a higher productivity and also have a larger impact per paper, as well as cumulatively during their career. But all of these were actually done based on isolated fields. And the opportunity arose for us for about 5 years ago to not look at individual fields, but look at science as a whole. And for that, we deconvoluted the gender of all scientists that worked in different fields historically. We identified each of their papers, and we identified their productivity as well as impact. And we did confirm what many other studies have shown, that when you look at the productivity of a woman or a man scientist, there is about a 30% or often bigger gap. Depends on the particular field. That is that men publish more than women. And that gap also persists in terms of impact. That is how much impact each paper has. But then came a twist and came a real surprise, which is we started to say, let's not look at the lifetime productivity, but let's look at the year-to-year productivity of man and woman scientists. And to our surprise, there was the difference between men and women on a yearly basis was negligible, which kind of raises an interesting question. If year by year, men and women roughly have the same productivity, then why do we have a lifetime differences in productivity? So we started to dig deeper, and what we realized is that is because women tend to end their career earlier for many reasons that we don't fully understand, but we suspect some of them. At some age, particularly at young age, women kind of disappear from the scientific workforce, mostly for childbirth and other personal reasons. And when a woman kind of disappears from the scientific community, but by the way, that is true for men as well. When a scientist disappears from the scientific community, not only the productivity ends, but also the impact decreases because the scientist is not going any longer to conferences, not publishing further papers, so it's not supporting his or her work. So we said, let's go ahead and not simply compare men and women across the board, but let's compare men and women who had the same career length. And then suddenly the differences between men and women have disappeared. And so the productivity, the lifetime differences were pretty much gone to zero. And also the gap in income has significantly reduced, not totally disappeared, but the bulk of the gap was simply explained by the different productivities. So in a way or the other, what we're seeing is that it's not that men and women have a different intellectual ability to do science, but rather for various reasons, women end their scientific career earlier than men. And that brings along not only changes in total number of papers, but changes in the impact of the previously published papers.
You have mentioned a few variables, but I would also be interested in, say, geographical differences, certain stereotypes that prevail in various societies. Have you looked at those?
Oh, absolutely. So we actually have looked at what is the gender gap across different countries. And we did find countries like actually the former Yugoslavia, where the gender gap was one of the smallest. And then we found other countries where it was actually very, very significant. Actually, Russia, interestingly, had a half and half woman and woman, actually. So like kind of in a way, the former communist countries have done much better in gender parity, mostly because typically it was less common for women to stay work. They were much more likely to actually be part of the workforce. And some of the traditional, and South America has, like Argentina was remarkable for a very, very small gender gap when it comes to participation in the workforce. But there was also something very interesting. So pretty much the number of women or the fraction of the women has significantly increased since the 1950s till today. And there's a gradual increase of the fraction of the women in the scientific workforce, which is good news. But interestingly, the gender gap started to increase when women appeared in the workforce. So with time, there are more and more women, but those who actually participate in the scientific workforce, they experience a bigger and bigger gender gap. So we have done very well of attracting women to the scientific workforce. Not enough, but we improved that, right? But with that, also kind of the gender gap became much more obvious. We're not good at keeping them. And this is exactly what was surprising to us, because we came to this research assuming that much of the loss of the woman from the scientific workforce happens relatively early in their career, or let's say mid-career, when they start to actually have families and they have other responsibilities they cannot manage together with the work. But what we realized that the gap we measured the rate at which women and men leave science, which is called the attrition rate. And there's always, on a yearly basis, a 3% gap between men and women. That is, a woman is 3% more likely at any moment to leave than a man, which means that, if you start with a pool of women, over 20 years, hardly any woman is left compared to the men. Men also leave, but because women left at a higher rate, there are fewer and fewer in the pool, so the pool gets rebalanced. And what was surprising, that this was not limited to that kind of young and middle age, but the high attrition rate actually was some of the strongest later in their career, as well as it was persistent throughout that. Which kind of our best guess is what happens is that there are so few women left in the workforce, that and they're offered leadership possibilities within university and other places, which takes them away from science. So they stopped actually being scientifically productive, but they're contributing in some other ways. They're becoming department chairs, they're becoming deans, they are becoming the presidents of universities. So I want to emphasize that some of the attrition that we see in science does not necessarily mean that women have left entirely science. It just meant that they stopped publishing research papers, which is kind of the measurable way we can see that you are an active scientist. But you may still be contributing very importantly to science through leadership roles, to administrative roles.
Well, that was quite uplifting to hear such findings relating to the gender gap and women in science. So thank you very much for your participation.
It's my pleasure.